welcome today to video 2 of our transformations unit. For today's lesson, you will need your transformation booklet. You should already have pages 2 through 6 complete. We're going to be working on page 7 in today's video. You'll also need 2 different colors to write with and possibly a straight edge. So let's go ahead and get started. We're going to start by defining our new word. You should already have these 4 words defined in your glossary: image, isometry, pre-image, and reflection. Today we're going to add translation. So go ahead and pause the video and get that definition copied down into your glossary. Alright, so a translation is a transformation where all of the points of a figure are moved the same distance in the same direction. A translation is an isometry, which means that the image of a translated figure is going to be congruent to the pre-image. And if you'll remember from past geometry units, congruent just means it's the exact same shape. So that means all we're going to be doing to this figure is sliding it around or shifting it up and down and right and left on your coordinate plane. So let's go ahead and get started. You are going to be turning to page 7 in your booklet. I am going to use a slightly larger copy so that you can hopefully see the words a bit better here. If I can get it zoomed right. All right, so I'm going to start by just writing down the rule for you, and you should have space up here at the top to write this. When you have a point XY that's being translated along a vector, and it will usually be written in this format where you have some number, comma, some other number with kind of greater than, less than symbols around it. Then the rule says that that is going to result in this point XY being transformed into a new point where you will be adding your A value to the X value. That's going to be your horizontal shift. And then you will add your B value to your Y coordinate, and that will serve as your vertical shift. And that will be your new ordered pair. So pause the video if you need to. Go ahead and get that rule written down. It's very important. All right, so what I'm going to do to get started is we're going to be looking at this pre-image of triangle EFG, with the vertices at E, F, and G. I am going to write my pre-image down. I know it feels like a waste of time, but I really think it helps to keep your work organized if you've got those coordinates listed out, because then when you do your transformations, you're going to be able to write those little arrows and show yourself moving from one ordered pair to another. So my point F is -2, 3, and point G is 2, -3. All right, then as always, the first set of directions is to graph the original coordinates. So I'm going to come down to my coordinate plane here and start plotting my points. E is at -5, -2, which means I'm starting at my origin and going to the left 5 and then down 2. I'm going to go ahead and label that coordinate with my E. And then my next one is -2, 3, which means I'm starting at the origin, going to the left 2 because I have a negative X value, and then my Y value is +3. So I'm going up 3 and labeling that point F. Point G, I go back to the origin and go to the right 2 because I have +2, and then down 3 for my Y value. I'm going to use my straight edge now to connect those points so that I can see my pre-image. It's very important that you have your pre-image down. All right, now I'm ready to start looking at these ordered pairs, and I'm going to start by using my rule to get my new ordered pairs. Now, just like with reflections, there is a way to do this more visually and less by the rule, but just as before, I'm going to show you how to do it with the rule first, and then I will show you how you can achieve the same end by just kind of using the coordinate plane against itself. So my new ordered pair then for my image is going to be, again, X plus A and then Y plus B. And I'm actually going to white this out and go ahead and put in the values that we need for this particular vector. So we were told in this problem that we were going to translate along the vector 6, 3. So that means to my x-coordinates, I'm adding 6. And to my y-coordinates, I'm going to be adding 3. And that's going to be my new ordered pair. So my image is going to be E prime. And in place of this -5, I'm going to have -5 plus 6 because I'm adding 6 to my x-coordinates. My y-coordinate was -2. I'm going to add 3. Okay? For f, I'm just going to go ahead and do all of my adding here. My x-coordinate is -2. My vector says I'm adding 6. My y-coordinate is 3, and my vector has me adding 3. And then g prime, my original x-coordinate was 2. I'm again adding 6. I'm adding the same thing to every point because the translation moves each point the same distance and the same direction. So then my original y for this point was -3, and I'm adding 3. So I'm just going to go off to the side and go ahead and do that addition for each one. So E prime, -5 plus 6 is +1. And if you need to do some scratch work or take out a calculator to verify this, you can. -2 plus 3 is +1. So my new E prime is going to be 1, 1. F prime, -2 plus 6 is 4, and then 3 plus 3 is 6. So F prime should be located at 4, 6, and then G prime, I have 2 plus 6 is 8, and -3 plus 3 is 0. So those should be my new ordered pairs. So I'm going to go down to my coordinate plane then and start plotting those points. E prime, I'm starting at my origin and going to the right one and up one. So that's my E prime. S prime, starting at the origin, going to the right 4 and then up 6. So 3, 4, 5, 6, and that's F prime. And then G prime, starting at my origin, I'm going to the right 8, 4, 5, 6, 7, 8. And then I don't go up or down at all because my y value was 0. So that's G prime. Okay? Now I'm going to connect those dots. And what you should see is a triangle that is exactly the same shape. It's oriented in exactly the same way, meaning it hasn't been flipped over or rotated at all. It is exactly the same. The only difference is it's in a new color, and I've shifted over to the right 6 and up 3, which brings me to your second method for solving these problems. It says, the definition of translation says that each point should be moving along a vector in the same direction and the same distance. So that means that really if you take this point, and I'm told that I am translating to the right 6 and up 3, then you really can, from this point, count over to the right 1, 2, 3, 4, 5, 6, and then up 3, and that's going to land you right on your new coordinate. E works the same way. I go to the right 1, 2, 3, 4, 5, 6, and up 3, and it lands me at E prime. And then the same will work for F. 1, 2, 3, 4, 5, 6, and then up 3. So that's kind of the visual method for doing it. Also, if you've done it right, you should know because you should be able to draw yourself those vectors and see that the lines connecting your pre-image to your image for each vertex is parallel. These lines have the exact same slope and they're the same length. So you can see that each vector is a parallel line to the other vectors. And that is translating a figure on the coordinate plane. So if you would like to rewind, look at any more of this, or go back and review, feel free. You should have this entire sheet completed when you come to class tomorrow.